Hi, everybody. My name is Reza Spagnolo. I'm going to talk today about adaptive application architecture. First of all, just short introduction. Who am I? I'm a student, as everybody in this room, I think, and forever will be. I'm an engineer for 9 years now. I'm interested in building systems. I'm not interested into just building parts of them, but I like to look at the whole. And I've been doing development and operations since the beginning of my career, and again, it's been the only way that made sense to me to actually look at things and do my job. All right. I also work for AWS, for Team Obstructs. And first of all, I need to thank the organization for having me here. I also want to thank them for letting me write this, as we got this awesome presents yesterday. Monitoring never sucked for real, that's clear, but what was started some time ago is producing a lot of good fruits, and we're seeing that. What I will argue today is that monitoring, and when I say monitoring, by the way, I don't mean just like the specific metrics collection system. I don't want to do in this talk a distinction between monitoring and alerting. I'm going to refer to monitoring as a generic term, and we all know that actually it's more complex than that, and we can draw some subdivisions there, right? But I will argue that monitoring is an architecture component that should be treated as such. Should not be a second citizen in the development process. Sure, I'm sure that it's not a second citizen for you guys, for people in this room, but it's also true that in the life cycle of a project, of a system, we don't always look at monitoring since the beginning, right? And we screw it up because of that. As we all know, infrastructure is code, infrastructure as code, and it's something that has quite some evident benefits, right? I'm not gonna say too much about this right now, but I wanna show this phrase because I argue the same for monitoring. So monitoring is code too, and because it's code, it's subject to certain things that code goes through usually, right? As such, first of all, it should be subject to a development process. It should be developed by the people that are developing the system, and they should do that at the same frequency with which they develop other components of the system. It should be actually embedded in the development process. I think it's even more important when the development process that you have embraces continuous delivery, so that say if you want to ship changes continuously to production, you should do that with a level of confidence that only having monitored your system way before it reached production could give you, right? Well, of course, it should be subject to testing, and I'm not saying that we should test the products that we're using, unless we're building our own, of course, right? But we should test our configuration, and we should test it not in production, all right? Although I'm not gonna argue now, and in this talk particularly, against testing in production. I'm actually gonna show a couple of things about that. As it's treated as code, monitoring should also be subject to deployment, right? And for those deployments, we should use the same kind of attention that we use when we deploy software. Of course, even more, possibly. Again, as monitoring is code, monitoring should be also service. And when I say that, I mean that an organization should offer internally its monitoring as a service, all right? This means that aspects like metrics and alerting should be available to everybody so that everybody can actually build on top of them, so that everybody can actually start innovating on top of them. I'm gonna adjust the microphone because sometimes you don't hear me, right? Yeah, all right. So I was saying, yeah, organizations that embrace this paradigm, organizations that open their metrics, their data to everybody, are actually seeing benefit in doing so, because ultimately people will start absolutely using that stuff, even if it's not coming from their own projects, but it's coming from other dependencies that they have. They will probably start consuming their dependencies metrics. They will start being much more aware of what those dependencies are actually doing, and they will have much more insight into the behavior of those dependencies. Okay, as we want to treat monitoring as code, or at least that's my intention, I would say that one very important part of it is that we should do namespaces. And we all know that, right? I had to write this quote here. Well, let me say it loud. There are only two hard things in computer science: cache invalidation and naming things. This is true, and the meaning is quite evident. What is also evident is that software sucks without namespaces, right? And as much as software sucks without namespaces, because we lose the organization and we lose the ability to identify things and to actually understand things, no matter if we have seen them before or not, same applies to monitoring. In this sense, we have metrics namespaces, right? So, what metrics namespaces are good for? Well, among other things, they're good because they help your mental model, right? They help your developers, and you, while you develop your system, to actually identify things, as I said, all right? And most importantly, as I also said before, the fact that you will be able, once your organization has leveraged a good degree of convention over configuration, you will be able to intuitively understand and identify what those metrics are about. About namespaces, some other things that I would like to say is that, of course, in your metrics namespaces, you should have dimensions, right? And as much as there can be many dimensions that apply to each case, and I'm not going to go deep into them, I think that two that are worth mentioning here are location and versions. When I say location, I mean, for instance, regions, availability zones, hosts, clusters, whatever applies to your case, right? About versions, well, those are the versions of the applications or of the components that we deploy. Because we should be able to actually compare metrics of one version with metrics of another version. And not necessarily this should happen only in your development stages, right? Well, I'm going to talk now a little about the, say, applications of monitoring in a development process setting. And what I'm going to talk about is monitoring-based promotion. All right, this is a very stupid slide, right? It's just like the simple, usual deployment pipeline where we see a development stage, an acceptance stage, and a production environment. All right. What's important here, what I argue, and sorry for not having filled this up with more say, pictures, is that we should use monitoring in all of those stages. And we should actually promote our software based on the results of that. I mean, Who wants to promote the production software that is guaranteed to breach thresholds that are already in place? In this sense, you would then test your promotions. I mean, you would allow your promotions based on the production configuration that you have in place. But in the same way, you should be also able to compare different versions of your software throughout this pipeline. Possibly, you could also do statistical comparison of any kind that applies to your specific case. Moreover, you should, as you do in production, do log analysis in your development environment. Because developers should know, I mean, I would like to know every time a change that I wrote has thrown a stack trace that I've never seen before, right? And I would like to know that as early as possible. All right. Talking about deployment, all right. Once we make the point of treating monitoring as any other software, then we have to think also about how to deploy it. The deployment of our monitoring software, it's not in scope here, of course. What is in scope is the monitoring configuration that and how we deploy that. All right. What we should do is, of course, be able to automatically push changes. And we should also be able to keep the correspondence between that configuration and the components that are corresponding to that configuration. Most of the time, if I'm pushing changes and my monitoring configuration doesn't align with them, well, those changes are likely to be not meaningful somehow, or I'm just missing the point of updating my monitoring configuration, and I will pay it later, of course. I should be able then, as I'm saying, to automate this whole process. And I should be able to leverage namespaces during this process, all right? One mechanism that I've seen working to do this simply, for instance, is to actually embed your monitoring configuration in your component. Because your software and your monitoring will live within the same namespace, then this is quite easy. I would just have monitoring configuration snippets across different components, and when I actually deploy them, well, my deployment engine should also take care of being able to update the configuration. And of course, it will not overwrite what's already there, right? Because I'm using namespaces, and I'm using dimensions such as versions or locations. Well, now, if we want to use monitoring during development, we have to actually do something more, because of course, it's not that only integration tests are gonna drive enough traffic, right, to our system. So, in this sense, of course, an important thing to do is to actually generate and drive synthetic traffic. This has importance both in development and in production. Well, driving synthetic traffic has a lot of value, and driving synthetic traffic can be initially quite difficult, but after all, it's actually not so complicated to do. One thing you can do is, it was said yesterday, and of course it has been said 1,000 times before, that you could capture production traffic and replay it against your development systems, right? One important thing to say about that, if you want to do that, is that you should really take care of anonymizing the traffic. Because disaster can happen if you don't do that. Moreover, your production traffic may not be meaningful actually if you don't put also the production state with it, right? You have to set up the initial conditions, then you set up the sequence of actions that you're gonna play through your system, and then you press play and you catch the results, right? And you observe it. But again, also that state that you set up should be anonymized, because otherwise you can, do stuff like sending emails to customers from your development system. All right. Well, another technique actually to drive synthetic traffic, another technique to do it actually easily is, we've seen it before, we have a deployment pipeline with a development stage, an acceptance stage, and a production stage. And in the acceptance stage, we will typically run our acceptance tests, right? We will run our stories automatically against the system we are developing. So in that sense, we can just take those acceptance tests, start having them emitting metrics, run them continuously, and here we go, we have a simple first initial form of synthetic traffic. All right, I was saying synthetic traffic during development is pretty important and enables the fact that I can actually use monitoring during development. Of course, when I say using monitoring during development, I don't mean that I want to get paged by my staging system, right? Another important application of synthetic traffic is, of course, synthetic traffic that we drive to our production systems. That's known usually under the name of this little guy here. Canaries, pardon. Well, canaries are a common name of synthetic traffic for production, and well, I think you almost all know why, and I'm not going to give you the full explanation. But yeah, just to say it very quickly, canaries are called like that because they were using mines, right? And they were using mines as early warnings. In this sense, they're also our early warnings because if a customer lets you know about a problem, then you have already failed at least twice. You failed once because you had a problem, right? You failed first and foremost because the problem was found by your customers. So your canaries should actually be there to prevent that. That's the first thing. And there I'm talking about top-level canaries, what you can actually drive from, say, against the entry points of your system. I don't have time to actually go deeper into the subject of using canaries in other parts of your system, but I actually support the point. We should use canaries at different levels because at the end, our system is composed by multiple components. So why not using canaries metrics for different parts nested in different places? This can actually make life easier when we are trying to understand what's the root cause of a complex outage we're facing in production. I will argue also that canaries and the traffic they drive should be in the right quantity, whatever that means for you. Point is that it should not overshadow, of course, your customer metrics, right? Actually, even better, you should be able to filter that and see the right picture. When you want to see the global picture, sometimes you will want to see the canaries picture only, and sometimes you will actually want to see only your customer picture, right? Of course, the right quantity also means if it's too high, it's bad, it overshadows. If it's too low, well, it's not meaningful. I'm not actually exercising my system. Now, once I do this, and I do this in production, a big pitfall of this is that if I apply any change to that, well, I should better document it, because otherwise you will have people staring at graphs and anomalies for 2 or 3 hours or more, or if you are on holiday, well, then good luck, right? So documenting changes to our baselines, as canaries are de facto establishing a baseline, that's very, very important. Then there are other types of birds. We've seen the pretty birds, but I like the most the angry ones. And there are also monkeys, but yeah, we're not going to talk about monkeys now. Well, we all know about monkeys, and we all know about what Netflix has started showing with the chaos monkeys, with the simian army, with the latency monkey, and so on and so forth. As much as I see a lot of value in using them, I'm always looking for solutions that I can apply immediately and that don't require too much effort on the organization. I wanna follow those directions, but I don't wanna wait months for doing that, for actually putting my system in the conditions in which I can start playing with those concepts. So something that lies in between is what I call the angry birds or the angry canaries. What happens there, it's, well, just a simple trick. It's no substitute to load testing, actually, all right, to proper and, say, rigorous load testing. But it's still a good, nice trick. If you code your canaries and your acceptance tests on a level of abstraction that you can configure, what you end up with having is that maybe you can do stuff like driving your system crazy with your same acceptance test and see how it reacts, right? You could start just opening connections and not sending requests. You could send half request half the way, or you could just, try to destroy your system and basically play Angry Birds with it. All right, we said about monkeys, and we're going to talk now about auditing. In this scenario, in what I said so far, this is very important. Of course, I was talking before about documenting changes to your baselines, and this is something also that I've heard yesterday quite a bit, and I think we all agree on that, that we need timelines. We need to keep track of what happens into our systems, and we need that information to be available anytime, especially when we need it, especially in the context that we present to a person that is wearing a pager and receiving an alarm, right? So in this sense, I mean, I think it's evident. We can just say that we should document and audit changes, deployments, rollbacks, alarms themselves, the activity of what happened before, and we should possibly automate the process of collecting this stuff for the guy that is actually receiving the page. All right, next I'm going to talk about architecture. There's not much time to talk about architecture actually today, of course, but I'm going to talk just about a few very simple principles that I think apply when you're thinking about drawing an architecture that can adapt to failure, that can react to failure. One first thing is the single responsibility principle. We should divide our architecture in a way that our components are doing a single thing and doing it right? We should, in this sense, also actually think about minimizing the number of dependencies that they have. Because this way, we can actually start understanding better their failure modes. One thing that you can do when you have a very simple component, and I'm going to change the slide, sorry, because I forgot that I had one about this. So one thing that we can do is to actually draw a failure matrix. You take all your dependencies and you start enumerating the way in which they can fail and the way in which that component can actually be affected. And the response, the automated response that you can have, if applicable, to that. If you are, say, skeptical about the concept of having components reacting to failure in production because you want to have the human factor kept in the loop, well, that's fine, I understand that. So you can start thinking about, okay, I would not let this component do anything about failure that I would not let, I don't know, a junior system administrator do, all right? So I would not let a failover mechanism bring 50% of my fleet down, right, or reboot it, but I would let it do it for 1 or 2 hosts and then continue after a while, or stuff like that. But getting back to the single responsibility principles, as I was saying, having a small number of dependencies lets you control them better and lets you have predictable failure modes. Let you also have an easy expectation and a clear expectation on the metrics that the component should emit. Because sometimes components get into production without emitting the metrics that they should have. But of course we can catch that in development when we use monitoring in there. Other principles. Orchestration or choreography. I'm going to go very, very fast because I don't have much time. About orchestration, you know, a system that is orchestrated is may be simpler to reason about, but you have a single actor there that is orchestrating different components, and you have coupling effectively. Choreography is another way to see it. It's possibly more flexible. You set up an initial state, and you have a system where components are not actually directly talking with each other, but are indirectly coupled, are quite loosely coupled. And they start observing the state around them and do things on that behalf without really talking about with other components. But of course, beware of the corruption of state that failures can lead in those scenarios, right? Other important things from an architecture perspective, dynamic configuration. Your system should be reconfigurable at runtime because you need fast reaction. And of course, if you start doing that, well, beware of producing snowflakes, right? Another thing is that if you start having failover, if you start drawing failover in your architecture, then you should be aware of feedback cycles that you may introduce. If your failover mechanism is actually producing more work for the system, is producing more stress, well, you have a feedback cycle that is probably going to actually accelerate the cascading failure instead of finishing it. Or it's going to make your outage last from 1 hour to 8 or 9 because your system is still processing that failover work. Another important thing is rate limiting. Of course, the graded experience is better than no experience, right? It should be applied not only at the top level. You could do component rate limiting too, of course, as I say, applied not only at the top level of your architecture. And, well, yeah, you can do other things like partitioning rate limiting. And after all, this is handshaking, right? And because it's handshaking, you could do it, depending on the situations, within the protocol or out of band. And when I say out of band, for instance, I mean that you could base your rate limits on the monitoring state while you are consuming your monitoring service through its API. I'm going to close with this slide, I think. I say that no matter if we start thinking about having architectures that are adaptive, that are failing over automatically, one important thing is also to work at the low level. And at the low level, when you look into the low level, many, many times you find, you know, things that are not quite right. For instance, you find a lack of applying actually this kind of patterns. Well, we all know what's timeout, but can you say 100% for sure that your system is using timeouts everywhere where it should? Can you say that it's breaking a circuit when it actually should? Breaking a circuit, I mean, to monitor the outbound call that I make to a dependency and just not do it when that call has reached over time a certain number of errors, for instance, or the frequency of error has gone too high, right? And this is an example in which a component is actually monitoring its own dependencies and breaking the usage, right? This enables also to fail fast, and it enables to do stuff like application pings and sanity checks. So when you do an application ping, well, it should be a bit more than serving an HTML page that says healthy inside, of course. We should actually sanitize all our dependencies, and we can do this kind of application ping at a component level and chain them together throughout our architecture, like probes or something. And yeah, those pings should actually use the sanity checks. The same sanity checks that we should apply when actually we start every single transaction inside our components. A good example of this is this library. Unfortunately, I don't have time to speak about it, but yeah, have a look at it. This is from Netflix, Hystrix. It's a collection of the patterns I was talking about. And if you want to know more about those patterns, well, a great source is a book called Release It. All right. Other sources that are worth having a look in this space are recovery-oriented computing papers from the, say, first part of the last decade. A good summary of what I've been saying and other stuff is in the James Hamilton Liza paper. Great book, Scalable Internet Architecture, and of course, a ton of others. Thank you.